For decades, we had a real problem understanding the outer solar system. Bigger objects like Makemake and Quaoar were tested for atmospheres and came back completely empty, while only massive Pluto seemed capable of holding on to any air. That left a gap in the science nobody could explain, until a team of Japanese astronomers solved it in the most unexpected way possible, by catching a tiny, overlooked rock, red-handed with an atmosphere it shouldn't have. I'm going to break down exactly how they solved this decades-old mystery, and what it means for everything we thought we knew about small worlds out there. Here's the setup. Way out beyond Neptune, there's a frozen ring of leftover debris called the Kuiper Belt. Think of it like the junk drawer of the solar system, billions of icy rocks that never got the chance to become planets. Pluto lives out there. So does this other object, a chunk of ice and rock called 2002 XVIS 93, named for the year it was spotted. It's about 300 miles across. For comparison, Pluto is nearly 1,500 miles across. This thing is a pebble next to it. For almost 40 years, there was only one rule about that neighborhood. If you want an atmosphere, you need two things: gas and enough gravity to hold on to it. Pluto barely qualifies. It's just heavy enough to keep a thin haze of nitrogen and methane clinging to its surface. Everything smaller than Pluto out there? Dead. Frozen solid. No air. That's not a guess. We've actually gone and checked. Astronomers pointed telescopes at bigger worlds like Makemake, which is over 700 kilometers across, way bigger than our little guy here, and found nothing. Zero atmosphere. Same story with Quaoar. Bigger rocks, no air. So, a 300-mile wide ice ball having an atmosphere isn't just unlikely. It's supposed to be flat out impossible. So how do you even find something like this? You can't just point a telescope at it and see a haze. It's too small, too dark, too far. Instead, scientists used a trick called a stellar occultation. Basically, you wait for this tiny object to pass directly in front of a distant star, from your exact spot on Earth, and you watch how the starlight behaves as it gets blocked out. If there's no atmosphere, the star just blinks off and back on, like a light switch. But if there's a thin layer of gas around the object, the light doesn't snap off. It fades out slow and smooth, because the gas bends the starlight on the way in. Here's the catch. This event lasts under 20 seconds. You get one shot from one exact location, and you have to be standing in exactly the right spot on the globe, or you see nothing at all. On January 10th, 2024, a team led by astronomer Ko Arimatsu in Japan set up telescopes at 3 different spots: Kyoto, a mountain observatory called Kiso, and a citizen-run scope up in Fukushima, because nobody knew exactly where this narrow shadow was going to fall. The predicted path had Fukushima sitting almost dead center. Kyoto was supposed to be a total miss, completely outside the shadow. Kiso was somewhere in between. It went almost backwards from the prediction. Kyoto, the site expected to see nothing, actually caught the longest occultation of the night, nearly 20 full seconds. Kiso got almost as long a look, and because the skies up there are darker, their data turned out to be the cleanest of the bunch. And Fukushima, the site sitting right on the predicted centerline, it never got a clean occultation at all. Instead, the telescope there caught something stranger. The starlight dimmed partway, then slowly came back, like it clipped the edge of something soft instead of hitting something solid. That something soft is the payoff. All 3 sites picked up the same signature, not a clean on-off blink, but a smooth fade. That smooth fade is the fingerprint of gas-bending starlight. This little world has an atmosphere. It's only the second object ever found in the Kuiper Belt to have one, Pluto being the first, discovered back in 1988 the exact same way. Now let's talk about how thin we're talking, because this is where it gets almost hard to believe. The atmosphere on 2002 XV 93 clocks in somewhere around 100 to 200 nanobars of pressure. Pluto's atmosphere, thin as it already is still about 100 times thicker than this. Put another way, this new atmosphere is somewhere around 5 to 10 million times thinner than the air you're breathing right now sitting in your living room. It stretches up roughly 40 kilometers above the surface, and it's likely made of methane or nitrogen gas. So this isn't a thick blanket. It's barely a whisper of gas. But a whisper is still something, and something isn't supposed to be there at all. Here's where it stops being just weird and starts being a real head-scratcher. Back in 2022, the James Webb Space Telescope already looked at this same object and took a chemical fingerprint of its surface. It found water ice and carbon dioxide ice sitting on the surface, completely normal stuff for a Kuiper Belt rock. But here's the important part. It found none of the ices that easily turn into gas out at that distance from the sun. No frozen nitrogen, no frozen methane, no frozen carbon monoxide sitting around waiting to boil off. That matters because that's exactly how Pluto keeps its atmosphere topped up. It's got surface ices that slowly sublimate, turning straight from solid to gas as it swings closer to the sun, then freezing back down as it drifts away, like a slow-motion breathing cycle. But 2002 XV93 doesn't have that reservoir of ice sitting on top, waiting to evaporate. So, if it's not doing the Pluto trick, where's this gas actually coming from? Scientists calculated something else important. Given how weak this object's gravity is, any atmosphere it built up should leak away into space within 100 to 1,000 years. That's nothing on a cosmic clock. This rock is billions of years old. So whatever's making this atmosphere either happened extremely recently, or it's an ongoing process that keeps refilling the tank. That gives us two real theories on the table. Theory 1, a hit and run. Some other chunk of ice out in that crowded belt slammed into this object recently, and the heat from that impact instantly boiled off a burst of buried gas, creating a temporary atmosphere that's slowly bleeding out into space right now, like a punctured tire losing air. Theory 2 is stranger, cryovolcanism, ice volcanoes. The idea that underneath that frozen crust, there's still some kind of internal heat, maybe from radioactive decay in its core, or maybe from a hidden moon tugging on it gravitationally, cracking the surface open and venting gas from deep inside, on and off, for who knows how long. Nobody's ruled either one out yet, and that's the part that should keep you up at night a little. A rock this small isn't supposed to have leftover heat inside it at all. If it turns out this thing really is venting gas from its interior, that means there could be thousands of other so-called dead objects out in the dark edges of our solar system that aren't dead at all. One planetary scientist who wasn't even part of this research, Scott Shepard from the Carnegie Institution, put it about as plainly as you can. He said this proves the Kuiper Belt isn't some cold, dead junkyard. It's actually teeming with activity and carrying some of the basic building blocks for life. That's a big statement for a 300-mile rock nobody paid attention to for over 20 years. So here's where we're at. A tiny world, 4 billion miles away, is doing something science says it shouldn't be able to do. And right now, nobody can prove exactly why. The next move is aiming the James Webb Space Telescope directly at it to sniff out the exact gases in that atmosphere and watching for future occultations to see if the pressure is dropping. Because if it is, that tells us we're watching a slow leak from an old impact. If it's holding steady, that tells us something down there is still active. Either way, we just found out the outer solar system has a lot more secrets than we gave it credit for. If this blew your mind a little, subscribe so you don't miss the next one, drop a comment telling me which theory you think is right, the impact or the volcanoes, and share this with someone you know who'd geek out over this just as much as you did.